Hey guys, I'm making this video just to show my method on how to do these hole punching problems on this PAT. Okay, so I call this the modified grid method because essentially it's the same, I use the same grid and I use X's, but I just use some of my own rules. So why is this a good method? Well, I could do these problems very fast. Even on the CDP, I could do them in 30 seconds. This is a quick screenshot I took. But you have to keep in mind that on the real DATs, they're going to be much easier than these problems on the CDP. So you could actually do them in 20-25 seconds. I took the DAT yesterday and I zoomed through this section and I used that extra time for the harder sections like the pattern folding and top front end. Okay, this method is simple. It takes care of the half holes, the invisible holes, all that. Occasionally you get this complicated fold that's kind of hard to visualize. Well, with this method, it makes it a lot easier for those types of folds. And lastly, the only thing that you'll be putting on the grid are the X's. You won't need excess annotations to signify half holes or anything like that. Okay, so there are 4 main rules. I wrote these out, but in truth, it's easier just showing you. But just for completeness, I wrote it out. So you're going to place the X's from the last picture onto the grid. Then you're going to locate the axis of symmetry and reflect all the X's that are contained in that shape over the axis of symmetry. Then you're going to, the X's that are already on the axis of symmetry get unchanged. And the 4th rule is that any X's that are present on the other side of the axis of symmetry are invisible X's. And you could just cross them out or ignore them. Okay, so I'm going to go through a problem. Okay, so I'm going to draw my grid first. Okay. So first thing, you're going to put the X's corresponding to the circles from that last picture. So one X will go here, here, and here. Okay, easy enough. Okay, then you're going to, so the whole gist of this method is to locate the axis of symmetry. I actually renamed this hole punching section ability to locate the axis of symmetry, because that's basically what it is using this method. So there are 2 possible axes of symmetry. It's either this one or this one. And you look at the previous picture to verify it. Okay, so that one's the same as that. So the previous picture would be this one. And you don't really need to visualize the fold in detail. You just need to know the gist of the direction of the fold. So you could tell that this was, moved to this corner, it was folded downwards. So you know that this is the axis of symmetry, which would correspond to right here. And next step is you're going to reflect all the X's that are contained in the shape, which is this shape right here, over this axis of symmetry. And so this would include this X, right? Because the shape, just to draw it out, would be like that, right? So we're going to reflect it over. And keep in mind, even though the axis isn't like shown here, it's kind of like extended. The axis is this whole line right here. And so this brings up a good point. For the 3rd rule, it says that X's that are present on the other side of the, X's that are already on the axis of symmetry get unchanged. So since these X's are already on the axis of symmetry, they are unchanged. So this would be the only thing that gets reflected. Okay, and keep in mind that I'm drawing, I'm drawing all these things on the grid just to show you, but on the real thing, I would do a lot of this stuff in my head. Sometimes I would actually draw the axis of symmetry if it's like a kind of a complicated, line that's like in the middle somewhere. I would just in case I draw it. Okay, so the last step, that's easy. The last picture is always easiest because the axis of symmetry is the one line right there, right? So you reflect everything in the shape, which corresponds to this rectangle, downwards over this axis of symmetry. So you're going to reflect all that over this middle line, downwards. Now this is another good point because this brings up my 4th rule, in that any X's that are present on the other side of the axis symmetry are invisible X's, and you can just cross them out or ignore them. So since we're folding the piece of paper onto a spot where there's already an X, then you know that these this x is an invisible x, and you just cross it out. And then you just proceed as normally and reflect it over, right? You were going to reflect these x's over the axis of symmetry. And that's it. So you know your answer is D. Okay, let's do another problem. Draw your grid. Wow, I'm really bad at drawing grids. Okay, anyway. Okay, so you're going to put the x's corresponding to the holes. So one would be here and one would be here. And then you're going to see here, the axis of symmetry could either be this line right here or this one, right? Based on this picture, you know that this corner is folded up in this direction, right? So you know that this has to be the axis of symmetry. Now I'm going to draw it out again. So the axis of symmetry would be this line right here, right? And so you're going to reflect all the x's that are contained in the shape, which would be this shape, over the axis. So these would include that x right there. This x is already on the axis of symmetry, right, with that third rule, so this would remain unchanged. Next. Okay, well, the axis of symmetry could either be this one right here or this long line. Based on this picture, you could tell that it was folded upwards, right? This bottom was folded upwards, so you know that this is the axis of symmetry. And so you're going to reflect everything in that shape corresponding to this little rectangle over the axis of symmetry, which would be here. Okay, and then the last picture is the easiest because you know the axis has to be this, and you're just going to reflect everything contained here over, which would, you know, encompass all these x's. Now with that fourth rule, we know that this is an invisible x because we're folding the paper to a spot where there's already an x, and then you're just going to proceed normally. And that's it. So your answer would be C. Third problem, and again I'm going to draw my grid. Oh, it's a really bad grid again. Okay, so I'm going to put the x's corresponding to the circles. Okay, like that. And then, so you're going to determine the axis of symmetry. You can tell that it's this one, right? Because if you look at this, you can tell that this little piece was folded some way to the right. So you know that this has to be the axis of symmetry, which corresponds right here. And then you're just going to reflect everything contained in that shape, which would be this piece right here, over the axis. So the shape would be like that, right? Then you're going to reflect these two over. Okay. And keep in mind that, you know, even though this little line here is half on the x, you know, that still gets reflected over. Keep in mind this is the axis of symmetry. So the x isn't on the axis of symmetry. Okay, and then you're going to look at the next step. Here, it could be either this one or this one, the axis of symmetry. Well, if you look at this, so this is a little more complicated, but you still could get the gist of it. That you know that this was, you know, this corner was folded upwards, right? It's kind of folded upwards diagonally. You don't have to picture it in detail, but you know that this was folded upwards. So you know that this is the axis of symmetry right here. I'm going to draw it out again, but again, I wouldn't do this on the real DATs. So this would be the axis, right? So you're going to reflect everything that's contained in this whole shape right here over this axis. Okay? This x is already on the axis of symmetry, so that it would remain unchanged. This would get reflected over, that would get reflected over, these two, that one. Okay, and then the last step, easiest, because you know that this has to be the axis of symmetry right here, right? Which should correspond to this line right here. And then you're going to reflect everything that's contained in the shape right here, over, which would include these three x's. But according to the fourth rule, remember, because we're folding the piece of paper to a spot where there's already x's, these invisible x's. These are invisible x's. And then you would just proceed as normally and reflect. Okay. I made it a little messy, but I mean, realistically on the DATs, I wouldn't like cross it out like that. But yeah, so yeah, that's the answer. So it would be B.